Hi guys, I'm back to give you another word problem example and show you how to use those 4 steps as a map to walk you through problem solving when we encounter these types of word problems. So let's get started. So as we know, we can use our 4-step map to help us problem solve when we're given a word problem. And what are those 4 steps that we use? The first is to identify. What are we identifying? All of the variables, which are the unknowns, and we're giving them smart labels. We're also identifying the constants, which are the known numbers usually that we're given in a problem, and we're also giving those a smart label. And we're also thinking about what units we want to assign to those variables and constants, and we want to make sure our units are consistent across all of our variables and constants. The second step is to translate, and what are we translating? English sentences into mathematics. We're translating those English sentences into equations, expressions, and formulas. So our requirements become expressions, equations, and formulas. Our constraints become inequalities, and we're ultimately trying to build a system of equations at this step. When we build our system of equations, we want to make sure that the number of variables we have is the same as the number of equations in our system. After we translate, we can move on to the third step, which is to solve. And at this step, the big thing is we're making a substitution so that we are left with one variable, because we can use algebra to solve for one variable. So we use our system of equations, and we take one equation that we substitute the others into. And we'll talk about that in more detail when we get to step 3 for the problem we're working on today. Finally, we want to check. And what are we doing when we check? We're really checking to see if our answer is a common solution and makes sense in context of the problem. So we're going to go back and plug our answer in to solve for all the other variables. We go back to our system of equations, plug in the answer that we got so that we can solve for the other variables. And then we're going to check to make sure that the math works and it makes sense. So let's look at our problem today. Today, our problem is coming from page 33 of our Algebra with Models student workbook by Marian Anton and Kieran Santoro. This is the workbook that we use in class every day. Let's read it. A right triangular artificial pond is part of a city landscape. The shorter leg is 1/4 times as long as the longer leg. How far will a duck walk from one end of the longer leg to the other if the area of the pond is 3,000 square feet? And notice it says at the bottom, round to the nearest hundredth. So when I read my problem, I read it 3 times. The first time I just read it like we just did. The second time I read it again and I start looking for important pieces of information that I might circle and star. So here I might circle that the shorter leg is 1/4 times as long as the longer leg. I would probably circle 3,000 square feet, things like that. And then the third time I read it, I really focus in on the question. So I'd read it a third time, and then I'd really think about what this question is asking me. So it says, how far will a duck walk from one end of the longer leg to the other if the area of the pond is 3,000 square feet? So I want to figure out how far this duck's going to walk. I'm looking for the measurement of the longer leg here, because the duck is walking from one end of the longer leg to the other, and I want to know how far that walk is. Okay, so we really focus in on the question, and usually when I read these, I make sort of like a movie in my head and visualize what's happening. So I'm literally visualizing a pond that's in the shape of a triangle and a duck walking across the longer leg. Okay. So now that we've read the problem 3 times, we've underlined or circled some important information, and we know what the problem is asking us to do, we can move into that map. We can move into our first. So now that I can move into step 1, that is the step where we identify. And what exactly are we identifying at this step? We're identifying the variables, the unknowns, and the constants, really the known numbers from the problem. We're assigning them smart labels, and we're assigning them units, okay? So each variable and constant, we need to make sure we think about what units we're working in, and it should be consistent across everything. So here I have my table. I always make a table at this step. I put variables on the left side and constants on the right. Let's take a look at the left side where I've listed my variables. Remember, variables are unknown, things we don't know. Well, this problem did not list any measurements for either the base or height of the triangle. So they are unknown. Therefore, we are going to assign them a smart label and units. So the base of my triangle I'm calling B, and the units would be feet. And the height of my triangle I'm calling H, and the units would be feet. And the reason I assigned them feet is because in the problem, it told me the area, and it said the area is 3,000 square feet. So I want to make sure that I keep that unit of feet consistent between all of my variables and constants. So now let's look at the right side of my table. And as I said, the only number we knew was the area. That we were given that in the problem. So we know it. It's a constant. It's not going to change. So I'm calling area A here, and the area was what? 3,000 square feet. So I have that listed here. Okay. Now that we've identified our variables and constants, we've assigned them smart labels and units, we can move into the second step. So now we can move into step 2, which is the translation stage. And at this step, I typically take a moment and make a sketch of what I'm working with. It just really helps me to piece things together and make sense of everything. So if you look in the top right-hand corner here, I've sketched a triangle. We are usually dealing with geometric shapes in these problems, so it is handy to make yourself a picture and label it with the information that you've worked through in the first step. So here I've got my triangle, and I've labeled it with both of the variables that we've identified in step 1. The longer leg is in blue. That was our base, and we named it B. And the shorter leg was our height, and we labeled that H in red. I labeled it H in red in my picture. And you also see that I wrote equals 1/4 B. We'll talk about that in just a second. So I like to make this quick sketch. It really helps me to think through things, because now I'm thinking, okay, the duck is walking along the blue side, the longer side of this pond, and I want to know how far it is from one end of this blue side to the other end of this blue side. That's what I'm really thinking about. That's what the problem was asking me. So now I can sort of visualize it a little bit better. So at this step, what are we doing? Well, we're really translating English sentences to mathematics so that we can build our system of equations. So we're taking our requirements, our English sentences that tell us what our requirements are, and we're translating them into mathematical expressions, equations, and formulas. And we're taking our English sentences that identify the constraints and translating them into inequalities. Just a quick note, in this problem, we do not have any constraints, so we will not have any inequalities. But it is important just to take a second and think about that, because other problems might have constraints that you would have to translate into inequalities. So we need to build our system of equations. That's our ultimate goal at this translation step. We want to walk away with some sort of system of equations in mathematics. We should have the same number of equations as we have variables in our system of equations. So it's really important when you identify your variables in step 1 to take note of how many you've identified. And in the first step, we identified 2 variables, B for the base and H for the height. So we know we should have 2 equations in our system of equations. And that's great for us to know. It's like a check that's built right in. So let's translate. In our problem, I'm just pulling the English sentences that we need to take and translate from English to mathematics. And the first sentence we're going to look at is that the shorter leg, which we called the height, is 1/4 times as long as the longer leg, which we called the base, okay? What jumps right out at me is that it says 1/4 times. You were given a translation sheet in class, but if it didn't automatically jump right out at you that times implies multiplication, you could have looked it right up on that translation sheet, and underneath multiplication, you would have seen the word times, right? The word times in English implies the operation of multiplication. So what are we multiplying by? 1/4. And how do we figure out how to write that? Well, whenever you see the word is, that's implying equality. So our sentence says the shorter leg, which is the height, is 1/4 times as long, which means that we're going to write that the height equals.
Hi, Mother.
And the height is 1/4 times as long as the longer leg, which is the base. So H, the height, is equal to 1/4 times the base, B. So we translated that English sentence into a mathematical sentence. H equals 1/4 B. The second thing we're going to translate, because remember, we need 2 equations, expressions, or formulas in our system. We had 2 variables. We want 2 equations. Well, we were also told what the area was, and we know the equation for the area of a triangle. So we can use that here. The area of the pond is 3,000 square feet. We called the area A, so A equals 1/2 base times height. That's just the formula for the area of a triangle. That's right on your formula sheet that you were given the first day in class, right? So the area is equal to 1/2 to the base times the height, and we know that the area is 3,000 feet. So we can set 1/2 base times height equal to 3,000. And now we've built our system of equations. We have 2 variables and 2 equations, which is exactly what we wanted. So we have our system. We can move to step 3. So now we can move into step 3, which is to solve. And your main goal at this step, you guys, is to make some sort of substitution. How do you make that substitution? Well, you're going to use the equations that you built in step 2, your system of equations. And you're really trying to figure out which one of those equations can I substitute all the others into. In this problem, we only have 2 equations, so we're going to substitute one into the other. If we had a system of equations that had 3 or 4 variables in equations, we would just be looking for one of those 4 to plug all the others into. So how do you figure that out? Well, you ask yourself which one of these equations encompasses all of the others, all the things that I've built here. So which equation encompasses all of my variables and my constants? That's the key here. That's the one we're going to substitute into. Because really what we're trying to do is we're trying to get ourselves one variable to solve for. We can use algebra to solve for one variable, but we can't really solve an equation for 2 or 3 or 4 variables. We have to just get it down to 1. So let's take a look. This is our system of equations. We had that the height was equal to 1/4 of the base, and we had that 3,000 square feet, our area, was equal to 1/2 the base times the height. So I'm going to ask myself, which one of these 2 equations encompasses everything I identified, the constants and the variables? Well, it's the second equation, right? We see our constant, the 3,000, plus we see both of our variables, the base and the height. Well, that's the equation I'm going to substitute into. So I'm going to substitute the first equation, h equals 1/4 b, into the second equation for the variable h. I know what h is. I translated it to the height is equal to 1/4 times the base. So I can take that and substitute it in anywhere I see an h. Well, I see an h in my second equation. I'm going to take 1/4 b and plug it right in where I see that h, which gives me now 3,000 equals 1/2 base times the entire quantity, 1/4 b. All I did was I knew that the height equals 1/4 times the base, right? We called the height h, so anywhere I see an h in that second equation, I can plug in 1/4 b, which is exactly what I did. Really important, guys, when you make a substitution, always throw parentheses around it, because if it has a negative or another operation is involved besides just multiplication, if there was like an addition sign in there or a subtraction sign, you need to make sure that you apply whatever operation to that entire quantity. So always put parentheses around your substitution, the entire substitution. Okay, we're going to then move into solving using algebra, right? Because at this step, we make a substitution and we solve. I just couldn't fit it on one slide. So let's continue step 3. Okay, so now let's continue this step. We're going to solve using algebra. Now, it's really important to realize why we did that substitution. We made that substitution because we can only use algebra to solve for a variable if we only have one variable. Before, we had a b and an h in this equation, and we can't use algebra to solve for 2 variables like that. But since we made our substitution, we got rid of the h and we're left with just the variable b, the length of our base, right? So now we can solve for variable b using algebra, which is exactly what we're going to do. And how do you do that? Well, when you solve for a variable, you guys, you want to isolate it, which means you want to get your variable on one side and literally everything else on the other side. So we need to get rid of that 1/2, that 1/4. We need to isolate our b, and we're going to use algebra to do that. All right. So here's what we've got. We've got 3,000 equals 1/2 b times the quantity 1/4 b. We're going to multiply 1/2 and 1/4, and b times b. We're basically just multiplying those constants and variables together, which gives us 3,000 equals 1/8 b squared, right? 1/2 times 1/4 is 1/8, and b times b is b squared. Now we need to get rid of that 1/8, so we're going to multiply both sides by 8 to cancel it out. What you do to one side, you always do to the other. When we do that, Our 1/8 cancels out and we get 24,000 equals b squared. Well, we still need to isolate b. We have that b squared. We have to get rid of the squared there. We have to get rid of that exponent. And how do you get rid of it? Well, you take the square root. We're going to take the square root of both sides because what you do to one side, you do to the other, which leaves us with b equals 154.92. We rounded to the nearest hundredth because that's what it told us at the beginning when we read our problem. There was a little note that said round to the nearest hundredth. I will always tell you what I want you to round to, okay? Circle your answer so that it doesn't disappear on you. And if we wrote this answer in English, we just solved to find the base, which is 154.92 feet. Okay, you always want to include the units there. So now we can finally move into step 4, which is to check. And what we really want to do is just make sure that we've solved for every variable and that our answers make sense mathematically. So remember, we had 2 variables. We had the length of the base, which we called b, and the length of the height, which we called h, right? Well, we just solved for the base in the previous step, but we still haven't solved for the height. So that's the first thing we're going to do. We're going to go back to our system of equations and plug in the number we just got for the base in order to solve for the height. So here's our system of equations. We know that the height is equal to 1/4 times the base. So we're just going to take our answer, 154.92, which was what we got for the length of the base, and plug it in everywhere we see b. Okay, so let's do that. H equals 1/4 times b. We know b is 154.92, so h must equal 1/4 times 154.92, which gives us 38.73 feet. All right, and again, I rounded to the nearest hundredth. So now that we know the base and the height, we can check to make sure that our area works out. We got to make sure our math worked, guys. We knew that our area should be 3,000 square feet. Well, now we know both the base and the height. The base is 154.92 feet and the height is 38.73 feet. So let's plug those numbers into our area formula, which was our second equation in our system of equations, to make sure that it does give us 3,000 back. All right. So area, remember, equals area of a triangle equals 1/2 base times height. Let's plug in 154.92 for b for base and 38.73 into h for height, which gives us approximately 3,000 square feet. Remember, you guys, we've been rounding this whole time to the nearest hundredth. So when you go and check this, as long as it rounds appropriately to 3,000, you've done it correctly. It might be a little teeny bit off because of our rounding, but it should be almost exactly 3,000 square feet. All right. So there's my little note. The answer will be slightly off because we rounded throughout this problem. As long as you get 3,000 square feet approximately, you've done it just fine, right? Our final answer. This is why it was so important for us to think about that at the beginning of this problem, to think about what we were being asked. We were being asked to find how far the duck is going to walk from one end of the base to the other. So we needed the length of the base, which we had called b. So the duck will walk approximately 154.92 feet, right? Which is what we got for the length of the base. And always circle it for me so I can see clearly what your answer is. So as you can see, you guys, these 4 steps are incredibly powerful when it comes to problem solving. How do we use them? Well, in the first step, we identify our variables, our constants. We assign them smart labels and units. Then we can translate our English sentences into mathematical equations, formulas, expressions, and inequalities. And our ultimate goal at this step is to build our system of equations. We want to make sure that the number of equations we have is the same as the number of variables we identified in the first step. Then we can move into our third step and at the solving step. And at this step, we're making a substitution so that we can solve for one variable using algebra. How do I figure out what substitution to make? I ask myself which one of the equations from my system of equations encompasses everything I identified in the first step, my variables and my constants. I'm going to substitute into that equation. Then I can solve for one variable. After I've solved, I need to check. I need to go back, use whatever solution I got in step 3 to solve for my other variables and to make sure that my math checks out. And then ultimately I need to ask myself, what was the question asking me? Make sure that I've answered it, okay? I know you guys can do it. Remember, don't get discouraged. It takes a ton of practice to get good at these problems. So just keep practicing. You can do it. Use these 4 steps. They are powerful and awesome. Good luck.